Welcome to all. Today we will see the topic curves in space or curves in Euclidean 3 space. So what actually curve is? So in order to know about curve, first we have to know about the position vector of a point in space. So for that we are having 3 coordinate system: x, y, z. This is the origin. P is a point which is given by the name the order triplet x, y, z. Then the vector OP is called the position vector of the point P. So with the help of the position vector, we will know what is the curve. So actually what position vector tells is, position vector tells about position of the point P from the origin. So where the point is from the origin, it tells about where the point exactly is. Hence we can write, if we know position vector, we can find the coordinates of the point. Similarly, if we know the coordinates of the point, we can know what is the position vector of the point P. For this, the position vector is xi, yj plus zk, and the length of the vector is, the magnitude is equal to x square plus y square plus z square. This gives the length of the vector OP. So the distance between O and P is the magnitude of OP. Now, a curve in space can be viewed in terms of position vector. So it's something but it can be defined as curve in a three-dimensional space, or space is locus of a general point P whose position vector depends on a single parameter. So in terms of position vector, we can say that, so if suppose we are having a curve, we'll take a point P which is on the curve. Then by considering the position vector at a point P from the origin, we'll come to know what is the position of point P about the origin. So we will find the locus of this point with respect to the origin. In that way, we will find what is the curve. So it is based on the locus of the point P. As I said, a curve in three-dimensional space is a general point P whose position vector depends on a single variable. Therefore, we will write the position vector OP as, I am taking it as R. This is equal to xi, yj, zk. This is such that x, y, and z are the functions of single parameter. That means x is a function of one variable t and y is also the function of same variable t, and z is also function of the same variable t. Means all of them are functions of single variable, means only one parameter. All of them are depending on a single parameter. So that is, it's about position vector. A curve with three-dimensional space is a locus of a general point P whose position vector depends on a single parameter. So here the parameter is t. Here it should be noted that all the functions f, g and pi, they should be single valued and continuous. So this should happen for the locus of the point P, general point P, to be a curve in three-dimensional space. So this is about curve in E3. Here it should be noted that the parameter t should be given a range, means the range of variable should be specified. Specified range should be there. So like t is less than equal to a is less than equal to b. So there may be t may belong to some interval ab, or some t belong to some closed interval, means the range of t should be specified here for the locus of P to be a curve. So we can see R is indirectly depending upon T. Therefore, what we can write is, as T changes, X, Y and Z in turn changes, and hence the point P moves. Which in turn give the path which is our required curve, which is the curve what we are in need of. So this is about curve. So what is the need of writing a curve such that the parameter such that it is depending upon a single parameter? It is due to the fact that sometimes, if suppose we are having complications in finding derivative, then this vector form of the curve is helpful, because everything is in terms of single parameter, so that we can directly differentiate or we can integrate. Therefore, the equation of the curve in terms of a vector is much better compared to other equations which are in terms of parametric coordinates. Let's see one example. R given by ti plus t square j plus t minus 1k. So this is a curve in E3 because it is depending on a single parameter t, and the corresponding functions, which are coordinate functions, they are all single valued and continuous. So this is a curve. Here the parametric equations are x is equal to t, y is equal to t square and z is equal to t minus 1. So to know geometrically what the curve exactly is, so what we will do is, we will consider two of the equations among these three. So first we will consider x is equal to t and y is equal to t square. So this gives y is equal to x square, which is a curve in a plane, and we will consider y is equal to t square, z is equal to t minus 1. This will give t is equal to z plus 1. So this implies y is equal to z plus 1 whole square. If suppose we take x equal to t and z equal to t minus 1, then we will get z is equal to x minus 1. So we are getting different surfaces by joining the equations. So taken two at a time. So these three are the surfaces. Now what we'll do is, we will take any two surfaces and we will find the intersection of any two surfaces. Any two surfaces we are considering and taking intersection. So that will give the required curve. Therefore, intersection of any two surfaces taken together will give the curve in space. So this is how we can view the curve in terms of geometrical sense. So one advantage of vector is, as we have seen, a curve in E3 is represented in terms of vector. Therefore, any curve which may be in plane or which may be in 3-dimensional or any dimensional space, it can be represented in terms of vector. Hence, we can write a note. So it says vectors cover any number of dimensions. Any number of dimensions. So we can see, for example, we can see a curve in xy plane. So we are taking a curve y is equal to x square. So the corresponding vector form of this curve is r is equal to ti plus t square j. So this is depending upon a single parameter, and from this vector we are having two parametric equations, x is equal to t and y is equal to t square. These two together will give y is equal to x square. So this is nothing but the parabola. Therefore, the two-dimensional curve y is equal to x square can be represented in terms of a vector. Hence, curve in any dimensional space can be represented in terms of a vector. Therefore, this is the advantage of the vector form. Hence, we can write vector curves any number of dimensions. So, if we take n-dimensional space, then we are also having a vector which covers n dimensions. This is x19. This is xn. Okay. So then this vector is called tensor. So the vector which covers n-dimensional space is called a tensor. So this is advantage of vectors. Means vectors converts any number of dimensions. Vector covers any number of dimensions, and is a locus of point which is depending upon a single parameter. So this is what exactly curve is. So we can represent a curve which is given in terms xi by j and jerky. As I have said, both all of x, y, z are depending upon a single parameter t. So we can write it as x of t, y of t and z of t with the corresponding unit vectors. So it can also be represented in terms of order triplet. R is equal to r of t, x of t, y of t and z of t. So this vector can be represented in terms of order triplet. It's all about how the curve will origin and how it can be represented in terms of vector form. Now let's see some examples of curves, three-dimensional curves. So the most famous examples of curves, examples for curves in E3. So as we are know, if suppose we are considering a straight line, what we know is, if suppose a straight line passing through x1, y1, z1 and which is parallel to the line with direction ratios proportional to ABC, then we will write the equation of the straight line as x minus x1 by a, y minus y1 by b, z minus z1 by c. So it is nothing but the parametric equation of straight line. But in terms of vector form, what we can write is a equation of a straight line in three-dimensional space which is given in terms of vector is, we can write it as, so r of t is equal to a plus tb, where t is a single parameter, a is a point and b is also a point, where a is a point such that the straight line is passing through this point, line passing through a, which is equal to a1, a2, a3, which is the order triplet, and b is a, which is a point such that r is Straight line is in the direction of the point B. This means the straight line is going towards the point B, so which is given in terms of order triplet B1, B2, B3. This is the equation of straight line in three-dimensional space. So which can also be represented as R of t is equal to A1 plus TB1, A2 plus TB2, A3 plus TB3. Likewise, we can write the curve straight line in three-dimensional space, which is in terms of vector form, which is depending upon a single variable t. We can see one more example of a curve in E3. What we are considering is a helix, which is probably right circular helix. Right circular helix means right circular helix. It is the helix obtained by right circular cylinder. So right circular cylinder is one in which base is perpendicular to the height and base is perfect circle, means the base is a circular base. We are having circular base and the height is perpendicular to the base. This is called a right circular cylinder. So the helix obtained on this surface, so this helix is called the right circular helix. The equation of right circular helix in terms of vector form is given by, I am taking it as R of t is equal to A cos t, A sin t, bt. So here t is a single variable such that A is greater than 0 and B is not equal to 0. Not equal to 0 means the z direction is not 0, means the curve is rising up along the z direction. This is about example for curves in E3. So these two are the very important curves in E3 which are in terms of vector form and which are depending upon a single variable t. So this is all about the introduction to curves in E3 and example for some standard curves. So next we will see what is velocity of a curve, because for every moving object it is associated with a velocity or speed. So we will see what velocity is in the coming section. So till then, keep watching. Thank you.